Melting and boiling. They're part of everyday life. We boil water to cook things. Metal is melted down to be recycled. A melting point is defined as the temperature at which a solid becomes a liquid. Further heating will eventually cause the liquid to reach its boiling point, when the liquid becomes a gas. Melting and boiling points of metallic crystals vary greatly. Using the atomic bond model, we can visualize this variation. Unlike other types of bonding where electrons are either taken from an atom or shared between two, the bonding of metal ions creates large amounts of delocalized electrons. These electrons form what is known as an electron sea, where the delocalized electrons move throughout the structure. The bonds formed here are what give the metal its excellent strength. Melting and boiling points of metallic solids are determined by the strength of the intermolecular bonds present. This strength is in turn determined by the number of valence electrons each atom has. Let's look at some examples. Because of their large atomic radius and only one valence electron, the group 1 alkali metals have some of the lowest melting points on the whole table. In fact, you could probably melt rubidium on a sidewalk on a hot summer's day. Gallium, found in group 13, has a melting point so low I could melt it in my hand. Wait, where'd my gallium go? In contrast, metals with more than 3 valence electrons tend to take much more heat to melt. Chromium, for example, is in group 6 and has a melting point just shy of 2000 degrees Celsius. Whew! However, when it comes to boiling, it's a whole other story. Metals, whether they have a melting point that is high or low, all boil at relatively high temperatures. Take potassium, for instance. Although its melting point is only 60 degrees Celsius, its boiling point is over 758 degrees Celsius. Compare that to oxygen, a nonmetal, which boils at negative 183 degrees Celsius. You see, even though it will melt with relatively low heat, the bonds formed between the metal ions are still very strong and will require a lot more energy to vaporize. Hope you've learned a thing or two about melting and boiling points. Now if you'll excuse me, I'm going to enjoy my melt. Tuna. Really good. Excuse me, do you mind? Thanks.